Boom. Okay, hello guys. We start our course today uh, with a new theme, right? And the theme is machine learning. But in order to delve into this new topic, we need to recapitulate what we discussed so far in order to put things in perspective better, you know. So, of course, I'm gonna start with the painting, as you well know. Are you guys on Discord? Can you hear me? Say something. Can you hear me?
Да.
Okay, cool. So now we need to understand the place of machine learning in the realm of artificial intelligence. Okay, this is what we're gonna talk about. So let's go on Wikipedia and just look for machine learning. See what that is. Okay, so please read the first statement there. It is said here that it's clearly a subset of artificial intelligence. Okay. So this is again a sentence that synthesizes what machine learning is all about. So you're all about the training data, okay, which is an abstraction over the raw sample data. And you need to manipulate this training data to process it in order to make either to make predictions or decisions without being explicitly programmed to perform the task. What do you guys get from this? Come on, let's have a discussion about this, because I think that if we discuss about it, we will get to a common point faster than if I'm speaking and you're listening. Okay, so let's talk about it. If you read the first sentences, what are your thoughts? Alexandra, did you read the first paragraph?
Yes.
Okay, so what do you think? How can you define machine learning? Now, off the top of your head, the first time we talk about it, like in your own words.
Well, in my own words, machine learning is just
It's a bunch of
some
algorithms that
that
do what?
process a lot of data.
Okay, okay. So how is this data given to us? In what form? What's a data set made of, or a sample data, let's say? Where do we get this from?
Well,
I'm sorry?
what do you mean?
I mean, let's say
What do you mean?
we are trying to develop a machine learning mechanism, okay? Uh, where do we get the data for the training set from? Who gives it to us?
Real life scenarios.
Okay, like what? Give me an example. Let's okay. Let's do this. Find an example of a problem that is either a prediction or a decision that can be made by machine learning. Just a concrete example.
The prices of stock markets or
The
a
prices of
price.
stock markets. Okay, but what would be the input? We're talking about the input now, right? Because this training data is the input data, usually. So what comes in? This is I mean, your example is a bit
All the stock
complicated.
symbol, the
I know, but
prices.
so what would be the output? What's the decision or what is the prediction? So
Day X, how much the stock will be.
so I just you're breaking up a little bit. So what did you say at the beginning? Like, what's the input? Is you have the prices for I don't know, some sort of Bitcoin or something in day 1, 2, 3, 4, 5K.
Yeah, for a company.
So for a company, okay, you have the value of the
Exactly.
stocks for a company in different days, and you want to predict day number K plus 1 based on the last K days. Okay. Okay. I like this. Guys, so then what's your input data then, if you model it like this? Hello? Can you hear me? Hello? Can you hear me? Oh, I guess you can't hear me. Why? Oh. Ah, you can. Alright, sorry. Somebody else, Andrada.
What was the question again?
So I'm gonna say the question again, right? Okay, so okay, can you hear me now on the Discord channel as well, right? You should. Is it better right now? Okay, so turn off the audio from the Twitch and hear me on this on the Discord. Can you hear me well?
Yeah.
Okay. Okay, so this is better. So Andrada, give me another example of a problem in which you need to either make a decision or a prediction based on some training data.
Well, you can predict the chances of a person to, I don't know, to get cancer, lung cancer or breast cancer based on training data gathered from many patients.
Man, what your insight on life is very grim. Like the first example was about money, then the other was about diseases. Man, what the fuck? I mean, why?
Well, we need to cure diseases, right?
Yeah, I know, but your kids, man, like you should give me more like puppy examples. I don't know. You bum me out a little bit, but it's okay. Yeah, very good examples. Correct. So you wanted to show the practical aspects of it. I understand, okay? Cool. How about all good? Let's take another example from Bogdan. Bogdan. Then, if not from This is Rob. Robbie boy. Are you with us?
Okay, so you need an example with cancer.
No, man. I need an example with a problem that is based either on a decision or a prediction on top of training data.
I don't know, the prediction to get all the students coming to your
So you talked about prediction so far.
Session.
Let's not predict anymore and let's classify stuff. Give me a problem of classification. Hmm?
classify students based on their I don't know, needs.
Okay, you have to be more concrete than that, man.
Okay. I don't know, classifying students by their faculty in order to see which form of training session would be an interest to them.
Okay. You give very complicated examples, guys. So I'm gonna give the simplest example ever, okay? So what is programming, in your opinion, Andrea? Computer programming.
For me, it's a set of instructions that the computer executes in order to obtain a result.
Okay, very good, very good. So you give the computer a set of instructions, and he has to just blindly execute those instructions that you give. Cool. So what is machine learning then?
For me, as I understand machine learning from previous experience.
Yeah, but who does
And
the
making a
learning? Who is the subject of learning?
The computer.
Correct.
But as I remember, because I watched some videos about writing recognition or something like this, is more about adjusting like an equation to be more precise when predicting.
Okay. This is part of prediction, right? But yeah, that's true. But the general idea is that you need to now, in machine learning, you need to give the computer the instructions that the computer can learn itself how to solve a problem, okay? So as a programmer, you just give the commands that solve the problem to your computer, right? And he solves the problem accordingly. In machine learning,
Yes.
you give the commands to the computer such that the computer figures out how to solve the problem on its own. Okay? Do you get this? So this is why it's
Yes.
called machine learning. It means that the machine is the one that needs to learn how to solve the problem. Pretty cool, huh? Briggy, what do you say?
Sounds cool.
Cool. I agree. So let's take an operation that makes the computer great, like a building block for what a computer does. So let's take the addition of two digits, right? So in the simplest form of addition, you have 0 plus 0. What are the possibilities that I can have if I was to add two digits, two binary digits? How many possibilities do I have?
Either 1 or 0 if the result
Yeah,
is
so how many possibilities? It's 4, right? 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1, okay? Do you agree?
Yes.
Cool. So who can tell me? Thor, can you tell me the results of this? Thor, are you with us? Okay, Alexandra.
Do you want the mathematical results or
The binary yeah, the mathematical results, but in binary. 0 plus 0 gives
0,
okay. 0 plus 1.
1,
1 plus 0. 1 again, and 1 plus 1.
0,
I'm sorry?
and it should be 0, and then we have 1 extra.
So it's 1, 0, right? In binary. That's the representation of the number 2 in binary, right? Okay? Then it means, in order to be consistent, that I need 2 bits of information to store the addition of 2 bits, right? Do you agree with this? So, as you said, this is an instruction that the computer has, like the addition of 2 digits, okay? Or addition of 2 integers, if you generalize it, okay? But what's surprising is that it doesn't even do addition, because if we look at these digits over here, and we think about logical operations, what logical operation has the following tableau of truth? So false and false gives false, false and true gives true, true and false gives true, and true gives false. It's only true if they're of polar opposite.
Exclusive.
Exclusive OR, right? Okay.
Yeah.
So probably you've learned. I don't think did you have computational logics as a subject in the first year, guys?
We had the mathematical logic.
Okay, but did you talk about logical gates?
Probably.
Probably. With which
Logical
probability?
gates?
Logical gates. It's like physical transistors in which what does 0 and 1 mean? In fact, 0 and 1 means electrical current passing through conductors inside your processor or your CPU. Okay. So actually, if you have a transistor of some sort, which is in fact an XOR gate, let's call it, what that transistor does, what?
We didn't talk about this.
Okay. But I'm telling you it now. I'm telling you now, okay? So it's very simple. You have some filaments that through which you have electrical current passing, and if the intensity of the current is low, then you have a 0 value for that bit that goes. So one filament is 1 bit of information, right? And then you have all the possibilities: low current with low current with high current with low current, and then you have high and high, right? So what comes out, so this transistor is manufactured in such a way that if you put low current with low current, it will give low intensity current. Then if you put currents of opposite intensities, it will give, either way, it will give high intensity current, and then it will give low intensity current if they're the same, okay? So the gate physically transforms the speed in which the electrons come out on the other end, right? Does it make sense? Guys?
Yes.
Okay. So you have to agree that if I get electrical current going into this gate, what comes out is this digit right here, the least significant digit of the addition. What about the other one? What do I need for this? What logical operation is this one? Guys? And. So it's false and false gives false, false and true gives false, true and false gives false, and only if both the statements are true and they're in conjunction, then the conjunction is true as well. So it's AND. So what I can do now is like duplicate the electrical current through other wires, and then make the current go into, into an AND. I don't know. I don't know the symbols, you know, but I'm gonna put another symbol here for that logical gate. You'll get what I'm saying. So this is another type of transistor that does another type of slowing down or hurrying up electrons, such that if you have either one of the currents is slow, it will get slow current on the other hand. And only if both the currents are high in intensity, you will get a high intensity for the current. And you can see that you have the input variables going here, and here. And then you have the output variables here and here. And that is why, if you remember from architecture of computer science, did you do that subject? Guys?
Yes.
Okay, so you remember that all the operations, so add, what was the add operation in assembly? What did you have to put for it? As parameters. Right? Right? This was the register, the AX. So the idea is that you take one operand from here, the other operand from here, and then the result is stuck in the place of the first operand here in AX. That's why it's called accumulating register. And now you figure out how this works, okay? All this is done in a part of the processor called the ALU. Do you remember what this is? Guys?
Arithmetic and logical unit.
Exactly. So it makes sense now why it's called like that, right? Because it performs arithmetical and logical operations, but you can see that we have this operation, which is plus, which is in fact done by logical operations. And at the end of the day, you can do anything with only logical operations, okay? And now if we revisit the logical operation, which are the basic operation that a computer does, how? Well, it has these gates, which are transistors, which are on those microchips inside the CPUs, which is the brain of the computer, okay? So using only these small transistors, it can perform logical operations. Pretty cool, huh? Guys? So logical blah blah. What? So what about XOR? Okay, let's check XOR, because this is the most exotic one, okay? So this is a XOR gate. Oh, so this was the symbol, okay? So as a matter of fact, you can see then you can build a XOR gate from what? From AND and OR, right? Do you agree? So it's A. How do you spell this? Who can help me? Guys.
My video is.
I'm sorry?
My video is frozen. I cannot.
So my video froze. Guys, can you see me properly?
Yes. That's a me problem.
Oh, okay. If you, but you can still hear me. Okay, I'm gonna do this as well then. Let me just do this. Okay, Thor, you can like try to contact me. You click on live in the Discord here, and you can check it on our group. Maybe it works like that. Okay. Okay, but let's take the simplest. Okay, so you can see that XOR is a more complex gate, right? Because it's built upon the AND and OR operation. So let's start with the simplest one, the AND logical operation. How am I gonna make my computer learn by itself how to what an AND logical operator is. Do you know where I'm going with this? So first, now the computer knows how to perform AND operations because we built it like that. So it has logical gates that have transistors in them that do that type of electrical current manipulation that leads to that, okay? But the computer doesn't know that he knows how to do that, you know? So we need to teach him how he does that. Or her, whatever. Is it cool? Do you understand where I'm going with this, guys? Just confirm or...
Yes.
So first I want you to tell me how can I make the computer learn the AND operation. What goes in an AND operation and what goes out? How many operands does the AND operation have? Is it a unary or a binary operation?
Binary.
So I have to have two inputs, right? Let's call them X and Y. Okay. As in Y is Gabi using airbrush. I'm sorry?
I just said paint.
Yeah, no, come on, Paint is awesome. Gabi is awesome. Gabi speaks about him in third person. Everything is okay. Okay, so these are the inputs and this is the output, okay? So let's say I'm giving X and Y and I know what it has to come out, right? So it has to be 0, right? And I can give it again 1 and 0 and it gives me 0, and I can give it training samples as many as I want, and it should be able to somehow deduce what the rule is, right? How? We will see. But we're talking about, look, if we go back to machine learning, it says that machine learning algorithms build a mathematical model based on sample data. If it's based on sample data, this is the initial entry point we need to talk about. So what is the sample data? The sample data usually is a table, like a comma separated values table or an Excel table or something, of input and output data. Do you agree with this, guys?
Yeah.
So this is my training. They said that it's called the training data. It's called the training data for a reason, because now I need to use this correct data in order to train my machine learning mechanism so that it learns my AND operation, right? How am I gonna proceed to doing that? First, I need to establish the composition of a data set, okay? If I look on the horizontal, like on a line of this the spreadsheet, right? What do I have? What's a line? How do I call a line? The information on a line is the information held for what? Guys? Alexandra? How would you call a line? How would you define it?
It's an equation.
Well, it has to do with training, so it's gonna be a training something.
Sample.
I'm sorry?
Sample.
Training sample sounds nice. What? Give me a synonym.
Data.
Everything is data. It's too vague.
Model.
How about this? Training instance. Does it make sense? Have you heard of this term instance before? And if so, where? Guys, where have you heard about instances? Hmm?
Pro.
Object-oriented programming, right? Can you, please, some of you please speak so if I can check if I can hear you properly. Andrea?
Yes.
Okay. So stay on the line, okay? So this is an instance. If I look at this, this is actually an instance that has some sort of actual value for the variable x, actual value for the variable y, and also it has the expected outcome for the variable z, right? So what if I take a column? Okay, what's a column then?
An attribute or
Exactly.
something like
Exactly. It's just like object-oriented programming, right? It's an attribute of an instance. An instance attribute. Okay? So that's it, okay? So you have input and output attribute, right? So these are the input and this is the output, okay? So it's clear. So in a machine learning problem, especially, okay, so look, you have now you need to see how you can split this machine learning realm into supervised learning and unsupervised learning. Have you discussed this before? Did you check the literature on the subject for your own interest before?
A bit.
So what is supervised learning and what is unsupervised learning? But give me an example from real life, okay? So, okay, I'm gonna give you an example, okay? So let's say I take Tom Sawyer and the prince from The Prince and the Pauper, you know? Mark Twain novels, did you read them as kids?
No.
Yes.
Okay. At least one of you, okay? If not, I suggest you do, man, because Mark Twain is the funniest writer ever. So, just a small parenthesis. Did you know that when Mark Twain was born, he was born on the exact date then the Halley comet was very, very close to our planet. And then he spent 73 years on this earth. And when he died, very roughly in the same period, probably on the same day, I'm not sure, it was again that the Halley comet visited us again. So my theory is that he's in fact an alien. You know, like he was like catapulted here to entertain us with his out of this earth humor. And then he did his job and bam, he went back. How about that?
Conspiracy.
It's not conspiracy, come on, man. It's just, it's fun if it's like that. If I'm right, it's just cool, man. Okay? We have aliens among us teaching us to have fun. You should be reading Mark Twain, man. He's like that guy cracks you up. Okay. Parentheses closed. So if you look at Tom Sawyer, who has street smarts, right? He's skipping school. He's going to live on an island with Huckleberry Finn and the guys. He is smart, right? He knows how to survive. He knows how to adjust to his environment and to make the best out of each situation, okay? On the other hand, you have the prince who's like the Prince of England, Prince of Wales, right? So this guy has had the best teachers any guy could have. So this is pretty much illustrating, I mean, if you look at them, maybe, and still, the novel of Mark Twain suggests that he learned more from the experience of being a pauper. Tom Canty, I guess, was the name of the pauper. As all the theoretical knowledge he acquired from from the best teachers in the realm, right? So these are the two approaches. Either you learn by yourself by facing, I don't know, the adversities of life, and you draw your own conclusions in an unsupervised manner, in which you don't get the cheat sheet with the good answers, which is this. In fact, you have to agree that this is the cheat sheet with the good answers, right? So that's an unsupervised way of learning. But if you go to school and learn the golden rule, so why are you acting like a bloody fool? No, I'm kidding. If you go to school, then you have a trainer who will teach you according to these cheat sheets, right? You can, that's what we all did. That's how we learned, right? If you didn't know how to do the exercise, you went, at least I know I did at the beginning, you went at the end of the book and you checked the answer, and then you made it work so that you get the answer. Did you do it like that? Guys?
Yes.
Yeah, so actually without knowing, you did the exact same thing we will see that this mechanism does, you know? If like, man, I got something way off, and you're like, holy smokes, how did I get that answer? You go back and you adjust what you did wrong so you can get that answer at least for that particular instance of the problem, right? But if you do so, you wouldn't have learned the method, you would have learned only that what goes correctly for that particular instance of the problem. And you don't need that. You need to learn the general algorithm to solve a whole class of problems. And that's the ideal here, okay? So, going back to this separation of supervised versus unsupervised learning, okay? We're gonna start with the supervised learning techniques first, okay? Because, let's say, it's easier to have the cheat sheet ready, so you can compare yourself to this, okay? So now, what I need to do is figure out a way that, starting from this set of input data, to make the computer train itself so that it figures a way to obtain the result in, let's say, all the cases, but most cases suffice. Let's say 99%. Okay? How am I gonna do that? First I need to establish, so we clearly established it's gonna be a supervised learning technique, and now we need to establish whether it's a classification or a regression problem. Guys, this AND operation learning, is it a classification or a regression problem? Is it a prediction or a decision that I'm making?
Decision.
It's a decision, okay? So it's even simpler than that. If I check here, I only have two cases, the ones with the zeros and the ones with the ones, okay? So I need to classify based on the input in only two classes, either the class of zeros or the class of 1, okay? So now I need to represent my data, okay? So I need to somehow envision how my data exists. But we did this before, okay? And now we're gonna come back to what we've done so far, right? To the part of artificial intelligence and how it affects the machine learning endeavor, right? So now I'm gonna create a new blackboard and see how I can represent these instances, okay? So let's say I have a plane here, a two-dimensional plane, and of course this is X and this is Y, okay? And this is Z, okay? However, the input points are gonna be located, so if this is 0 and this is 1 and this is 1 here again, then I have pairs of points, right? Like in a Cartesian notation, I have 4 points. This is the point called 0, 0.
Origin.
Yeah, it's the origin. Whatever. This is 0, 1, I guess. No, it's 1, 0, right? Yeah, it's 1, 0. This is 1, 0. This is 1, 1. And this is 0, 1. Because it's 0 on the x and 1 on the y. Do you agree?
Yep.
Yeah, but going back here, let's denote these instances separately. So this guy right here is I0. This guy right here is I1. This one is I2. Because I too love machine learning. I3. I4. Just bear with me, okay? I5 and I6, okay? So now let's see where my eyes are located, okay? I'm gonna move it to half the screen and push it like this, okay? And now I need to see how I'm representing this now. So you can see I0 is in fact located here, right? So I can say that this is I0. Then I1 is 1, 0, so here I have I1. I2 is way up here, okay? I3 is again here. I4 is again here. So I can have duplicates in each of these points, okay? Because I have only 4 choices to make and they can repeat, okay? So I don't have a 0, 1. Let's make this one a 0, 1. So 0, 1 gives me a 0. Okay, so I have, which one did I put? I put I4, I5 is 1, 0, it's also here. And then I have I6. Okay. Are you following? Is it okay? Guys, Andrea, Andrada.
Yeah, it's okay.
Andrei?
Yes.
Bogdan?
All good.
Brigi, Gabi? Loredana și Monica? I'm just taking attendance a little bit.
Yes, yes.
Okay. Is it interesting so far? Am I boring you? Okay. We haven't done anything yet, but we'll do right now. Okay. So now I have this representation of points, and can you tell me what classifying these points really means? Hey, ideas. Alexandra.
Finding a potential function.
Okay, what kind of a function?
Binary one. I mean, for binary input.
Binary. Yeah, but I'm not. A function has a graph. How would this function graph be like?
It should be a line.
Correct. That's what I was going at. So, in this
Okay.
plane x or y, right? If I draw a line, I'm gonna draw it with yellow or something. Okay. If I draw a line like this. Oh man, that's not good. So if I draw a line like this, man, I'm bad. Like this, okay? Is this gonna?
You have the line option in Paint.
I know. So if I draw a random line, what's the equation of this line? Hey, Mate Info, come on. Hit me.
X plus Y equals
Y equals
Equals what? A constant,
yeah.
right? Or I can say plus a constant equals 0. Is it okay? Like this.
yeah.
Everybody is okay with this expression of a line function. So actually, the x and the y, they're like the what? The coordinates of x and y. That it's the same stuff as
But
here.
don't we have a 3D image?
What?
Don't we also have the Z coordinate?
Yeah. Well, we're not gonna use that. The z.
Ah, okay.
Because how am I gonna think about this? So if I have this equation, right? So I'm gonna write it up here. So alpha x plus beta y plus, let's call it gamma, okay? To be consistent, okay? So if it's an equation to 0, then it defines this line, right? So this equation, if it has equal, it just defines the infinity of points located on this particular line, okay? But if I do an inequality out of the equality, I can either do it less or more. So less means the whole space underneath the graph. So all this, oh man, this is not good, okay. All this region right here is satisfied by the inequation, this one, right? Guys, do you agree?
Yes.
And the points for this will be located from here, okay, onward up on this semi-plane above, right? So this in equation with greater, it characterizes this semi-plane generated by the line, and this with less generates the semi-plane underneath the line, correct? Bogdan, do you agree?
Yes.
Pretty cool, huh? So that means if I draw the line correctly, the line itself can then classify, I can label this 0 and this 1, or vice versa, and that will represent the two classes on the Z, right? Does it make sense? Who asked me about the Z coordinate? Does it make sense now that I'm not using the Z?
Kind of.
Okay, what if kind of? Let me know why.
I didn't get what is 1 and what is 0.
I'm sorry? You're breaking up a little bit. Tell me again. What is 1 and what is 0?
I don't understand the 0 where they are on the graph.
Well, any point which is underneath the line, let's say it will be named 0 on Z, and any point above the line will be characterized as 1, let's say. You understand now? So you take one of these points. Each point, each eye, has its own x and y coordinates. Okay, so it's gonna be x4 and y4. Okay, and you put these coordinates as input here and here for this particular alpha and beta and gamma. And if the value is above 0, you will get it to be labeled 1, and if it's below, you will get it to be labeled as 0. Do you understand now?
Yep.
Alex? Danila?
Am venit numai acum și nu știu.
Ok. Alexandra? Vrei ceva să adaugi până acum? Cum? It makes sense, right? Andrada?
Yeah, it's okay.
Andrea? So you guys knew about this? Did you learn
Okay.
about this machine learning before? On your own?
I didn't.
Okay. Cool. So feel free to join me and talk about stuff, okay? Brigi, do you want to add something to what I said?
No.
Okay. Is it okay? You think it's correct what I said?
Yes.
Okay. Thank you. Everybody needs reassurance, right? So we're moving on. The idea is that I'm gonna start with a random line, okay? So let's check a little bit what are the parts of this equation, right? So I have this. I have x multiplied by alpha. I have y multiplied by beta. And I have this gamma. So I can say that x gets multiplied by alpha, goes here. Y gets multiplied by beta. And then they're all summed up together. I'm gonna use the sum. Okay. And then I need a result from this that can either be 0 or 1. Does this describe what I'm gonna do? Does it make sense? Is this what happens? So what I need to learn is in fact these alpha, beta and gamma. These are the values that I need to let the computer strive to learn. Okay, so if he gets the alpha, beta and gamma right, that means that he will have a trained classifier for the AND operation. Okay, so the first mechanism in machine learning that we're gonna discuss now comes from nature. Okay, so probably I mentioned that my sister, she's a biologist, she's a genetician. geneticist, how do you call it? Geneticist? I don't know. You know what I'm talking about. So she always mocks me for my lack of genetics knowledge, okay? But I know this, okay? So I know a little bit about biology, the part that still stuck with me after high school, okay? So the idea here of taking some sort of information from the exterior, multiplying it with some weights, and then corroborating all these summations in a central point, and then coming up with an answer that comes on the other side, it must look like something that we talked about in biology class, right, guys? Like what? What does this look like? Any ideas, Briggy? Andrada?
It didn't let me unmute myself.
Cum?
It wouldn't let me unmute myself.
Ah, okay. So you have some multiple sources of information that are coming from here. So the flow of information comes from here. They're going to a central point after being multiplied in a way with a weight, and they're all corroborated in this region here, where some sort of processing is being done, and then the result is passed along through a unique output from there. Does this look familiar from biology?
Describes a neuron.
Yeah, so I don't know. I always make neurons look like hands when I draw them, right? So it's gonna be like, so okay, so now I have the blah blah blah, and then write something like this. So now you have like some spiky little things here, pam pam pam, nervous terminations or something, how do you call them? And then let's get the proper denominations for this. How do you call this? These things. Guys? How are these guys called in a neuron?
Dendrites.
Dendrites or dendrites, I guess. Correct. So dendritas. Now they all emerge into the nucleus, right? So this is the nucleus. And then the information is passed out of the nervous cell through what? What is this? Guys?
Axon.
Okay. Don't you think it's the same principle as here? So let's say here is your epidermis, right? And there is a very power stimulus here in this region, right? And somehow the nervous system has to tell your brain that you need to be on alert because something bad might be happening to you. You're being attacked, right? Do you agree? So what you get here in this are some input variables with very huge values, right? It's like alert, alert. So these information that comes from the outside is now gonna be multiplied, right? Is gonna be multiplied with the weights that come here, and based on the importance of this particular dendrites that was priorly established, then based on this, together with other stimuli, the nucleus will figure out what to do. If the result is above some threshold, it will pass the information along to other neurons through how do you call the link between an axon and a dendrite? This space here in which you transfer information from the terminations of an axon into a dendrite.
Synapse.
Correct. So you link neurons via synapses, okay? So actually a neuron is not much if it's alone, okay? So that's why all the jokes with, I don't know, persons having 2 neurons are funny, I guess. But you need a network of them for it to make sense and to learn more tricky tasks, okay? Like, you know, a human body and an animal body is a wonder simply because we have our nervous system that is so intricate that allows us to get out of tricky situations, right? Run, do stuff that we don't even have control over, like reflexes and so on and so forth, okay? So clearly what we're trying to do now is to figure out how this machinery, which is our brain, actually works, okay? But we start from the lowest part of it, you know, like starting to figure out what is the basic operation of a computer, which is this addition, and then figure out how to train a computer to do at least that, to learn how to do what he knows, what is the basic operation that it does, okay? So how many neurons do you think we will need for this particular operation? Andrada?
I'm sorry, I wasn't paying attention. Can you repeat the question?
Yeah, it's cool. So the question was, how many neurons do you think are necessary for us to perform this task, okay? The task of learning the AND operation.
As many parameters as we have?
No. Because the parameters are the information, represent the information that goes in the neuron. Look, here. These are the number of dendrites that you have on the neuron.
As many.
So for this particular problem, I have X and Y as inputs, and Z is only 1. But the question was how many neurons are necessary. Andrea?
I think 1 is enough, and the parameter.
Okay, so 1 is enough. I agree with that. Okay, so I'm gonna create another blackboard for this. And now, actually, you guys remember that the last time we discussed about genetic algorithms and how we, as, I don't know, artificial intelligence, let's say scientists if you want, like researchers, and we as humans try to replicate nature, okay? So it's the same thing here. We try to create a mathematical construct that emulates a neuron, okay? So if the neuron was like this, okay, I'm gonna draw a little bit of a neuron here. I'm sorry guys for my poor artistic talent, okay? So this is the neuron, okay? So you have stimuli going through the dendrites, and they all reach the nucleus, and then the signal that comes out is transported outside via the axon, okay? So in mathematics, it's like we said before, right? So I'm gonna have a bunch of entry points, which are the dendrites, okay? So I'm gonna have an x, I'm gonna generalize it to more variables. So I'm gonna have x1, x0, x1, x2, how many, it doesn't matter. So I'm gonna put n here, n minus 1. So I'm gonna have a vector, an instance of n input data. I will put the c here as well. Okay, never forget plus c, but you know what I'm talking about. And now we need to model the importance of each input factor. So I'm gonna have a weight assigned, a corresponding weight assigned to each of these input links, the dendrites, if you will, of this mathematical representation. Okay, this one doesn't have a weight, right? Because it's the free term. And now I go with all this into the core of my mathematical construct. And what I need for it to come out is a value that I like to keep within either the realm of 0 and 1 as a continuous segment, or in the set of 0 and 1, okay? So here, what I do here, inside this black box, is I do the ponderate sum of this, right? So it's gonna be, if I can say that it's sum of I from 0 to n minus 1 from what? xi times wi. Do you guys agree with this?
Yes.
Okay, so now I need to set some constraints, right? So I need to put this between 0 and 1 as well. For starters, okay. And of course, you can see that in my case, let's say that my input is either 0 or 1, okay? Okay? Do you guys agree?
Yeah.
Okay. If I have all these constraints, the x's are either 0 or 1, the weights are between 0 and 1. What can I say about this? How big can this get?
Also between 0 and 1.
That is not
Oh,
correct.
no.
That is
Yes,
not
no.
correct. This can go to
between-
infinity.
Yes.
Right? This can be getting very, very big. Do you agree? Because if this, the number of these guys, I'm putting 1 on all this because it's an accepted value, and then I have positive, I put 1 on all these weights, okay? And I have an infinity or a huge number of inputs here, right? So the sum is gonna be a huge number, right?
Yes.
Okay, so this is the perfect example of what you see in American teenage movies, you know, like when they are being presented don't do drugs videos, right? So it's exactly what happens. Don't fry your brain, okay? If you let this value, it's like an overdose of information, and it will fry the infrastructure of your nervous system, okay? So in order to not do that, you need to maintain this in this region of 0, 1. How am I gonna do that? Do you agree that it can escalate really quickly, the value of this sum?
Yes, I think if we make 1 over this sum, then the result will be between 0. Like
what if this gets
0?
Yeah, okay. But what if I put here values very close to 0 multiplied with values very close to 0, right? 1 over 0 gives infinity. So you were thinking of the case when I blow up these weights and the inputs. But what if I blow it down? You know, if I put small, I mean zeros here, you know, 1 over 0 goes to infinity. Again.
Yes.
So it's symmetrical. You try to get out, but you found out, you found the other bad case, right? What else? We're programmers and mathematicians, so let's figure out a way that works. Whatever I'm giving it, it doesn't matter. It still keeps the values between 0 and 1. What's that?
What if we do modulo 2 and take the rest, and that will be between 0, either 0 or 1?
Okay, okay, but what's modulo 2?
The rest of the
No,
division?
what is it? What is it?
Right.
Mathematically. What is it? Modulo 2.
The rest of the division.
Yeah, but what is it?
Right.
What is it? Plus, minus, what are those? How did you define them in algebra, man?
Modulo classes.
They're relations, right? Guys. Guys. Relations. Did you cover the topic of relations? As subsets of pairs of the Cartesian product in algebra. Yo, math info. Tor. Andrada.
Yeah, we probably have.
You probably had. Okay. So, come on, guys. Like, how do you define the less or equal relation? You create the Cartesian product as the combination of all the elements in your set, and then a relation is a subset of that Cartesian product. And, guys, come on, algebra. Right? And the generalization of that is a function. We need a function here. Why didn't you come up with this answer? Like, I have a function that has the domain R, and whichever I give to that function, it keeps the output into 0 and 1. Do you agree with this? Or into either 0 or 1. Guys. Andrea.
Yes, I agree.
So it's an elegant thing, right? Whatever comes at me, I reduce it to this or to this. Okay? Alexandra? So, how do you call this function? What's the name of it?
Some sort of reduction function, I'm guessing.
So, if you think about biology, what does it mean? So, you have the information going from the stimuli into the nucleus, and then what is the task of this neuron on the axon?
Process and pass on that info.
What does that mean? It means that it activates. It has to decide whether it activates the value of 1 or not the value of 0. Okay? Do you agree?
Yes.
Okay. So, this is called then, logically, an activation function. Do you agree?
Yes.
Because it tells the neuron whether it should activate its axon or not. If you put either 0 or 1 there, it can either be active or passive. If you put a value between 0 and 1 there, it shows you the degree to which you are being activated. Right? So it gives you more flexibility. Do you agree, Andrada?
Yeah.
Okay, Bogdan? Andrei? Brigi? Okay. So, How, Briggy, how do you call this contraption that we talked about? This pseudo neuron? What's the proper name for it?
Was it axon?
Hmm? No. It's like the computer version of a neuron in machine learning. It's more than meets the eye. It's called a perceptron. Okay? Okay? So a perceptron is nothing but a function, an activation function applied over the bounded summation of some inputs multiplied by weights that gives us a result. Then the result can be used in what? For our purposes, let's say it can be used in binary classification, right? Because it gives either a 0 or a 1, which is what we need, right? Because if you look at the output of our problem, it's all we need, right? A value for 0 or a value for 1 based on the zeros and ones we get as x's to our goals, okay? Questions so far? Come on guys, I really need questions. We need to talk about it. So you don't have any questions, guys? Come on, let's talk. Did you? Okay. Did you get this?
I understood.
So, if you understood, tell me how can we use a perceptron to make it learn the AND operation?
Well, we have the values from we have for x0 and x1. It can be either 0 or 1.
Yeah, but how does it learn? Because we didn't talk at all about the learning process, okay? Because we only talked about the structure of a perceptron, right? That it has these weights here. Who would like to talk? I mean, Briggy, I would like you to tell me. How does this guy learn?
They're from the previous.
What?
I was not here. I was not here when you went over that.
Over what? I didn't go over that. We're going just now. We just talked about the structure of a perceptron. Are you okay with this? Did you pay attention to this?
Yeah.
Okay, so now we're gonna put this rascal to work, right? So for our actual problem, right? So let's see. You're gonna help me if you want. Will you?
Yeah, I want to understand.
Okay, so let's say we have this input data, okay? So actually, for my perceptron, the input will be x and 0 and y. X and 0, man. So x and y. So in turn, I'm gonna give it 0, 0 to input here, okay? Do you agree? Here I'm gonna have a w for x. Here I'm gonna have a w for y. And it goes inside of this neuron that actually does this. Applies a function f over x times wx plus y times wy. Okay, were you paying attention before about what this f is and all this?
I only got to the end part.
I'm sorry?
I only got my laptop when you were at the end.
Okay, so
of the explanation.
I said that x and y are either, they belong to either 0 or 1, right? Okay? Do you agree? Okay, so now I have to input some weights here. And then I need to apply this f. Do you know how I call this f? Activation function. Okay?
Alright, yeah.
So I said that this sum here inside, do you understand the sum here?
Yes.
So I multiply the x with the weight and the y with its weight. Okay, so this sum can explode out of the 0 and 1 realm, which I need on this side over here. So at the end of this, I need something between 0 and 1, okay?
Okay.
Cool. Or I need something that is either 0 or 1. It depends, okay? For binary classification, I will have this one, okay? This is what I'm gonna need, okay? So in order to keep the values that can blow out of this realm into the 0 and 1, f is gonna be defined as a function that takes any real number and gets out a number between 0 and 1. Okay? Do you agree?
Yeah.
Can you give me an example of such a function? How will this look?
Like, we want to, so if you want to check that something is how I want it, like it can be a function that checks if
Well, let's see.
two numbers.
Okay, tell me.
If like two numbers, the sum of two numbers is equal to something we want, then it's 1.
Yeah, but
like
let's go back to the example from biology, right? If
Okay.
somebody just mildly touches my arm,
Okay.
the value of that stimulus, namely x and y, will it trigger my reaction?
Yes.
No. If it mildly, I mean, I'm not gonna get into a fighting stance if you press your hand on my shoulder, right?
What if it scares you?
It's a mild touch. Okay? Okay? So
Okay.
that means that if the stimulus is low, if it's located here on R, this is the stimulus, the intensity of the stimulus. If it's from here, the activation should be close to 0, right? Do you agree? Because it's called an activation function, the degree to which you get activated by a stimulus, right? So if the stimulus is low in intensity, namely onto the left side of this axis, you should have 0 here, right? So the first function like this is called a step function, which is very simple and not at all nature-like, you know? Like, you say that up until one threshold, which is established like by yourself or something, nothing happens, and bam, everything after that is 1. You're fully activated, you know? Do you agree with this?
Yeah.
So it's like black or white, 1 or a 0. It doesn't leave room for some gradual progression of things, okay? And you can clearly realize that this is not how things happen in nature, right? It's not just black and white. That's why they made that movie with 50 Shades of Grey, I guess. Only true programmers know that there are 256 Shades of Grey, right? Come on, you don't like my joke.
It was okay.
Okay. So the idea is that it never, even if in the case of water boiling, you don't get from liquid water to full steam in like snap, right? It has to be some sort of a process that gets you from one point to the other, right? So maybe it's better to define this activation like you say, starting from here, you begin to get more and more active, and up until this point here, you get fully activated, and you just draw a line from here. Do you agree with this? Is it more close to what happens in when we get activated?
Yeah.
Right? So
Yeah.
this is more like it. And it's an easily implementable function, computable function, right? Because you have one horizontal line, another horizontal line, and an oblique line, right? But also, have you seen natural hills in nature that have this shape? Like it goes straight, then boom, like a perfect line, and then straight again. Like the hillside. You never see a hill that has this shape unless it's human made, right? So what are the hills in nature shaped like? What is their form? Some other Andrea, can you tell me? More smoothly, right? Something like this. What do you say? A shape like this? Guys?
It doesn't look more smoothly, it looks more wavy than
that wavy
one.
is smoothly. What do you mean? Like this angle right here is a right angle, right? If you go like this, it's smooth, right? You don't break the angle like before. You don't, I mean, the side of a hill, doesn't it look like this? In nature. Like if like sediments fall from here, they will have this shape. Naturally, right? Alexandra, do you agree?
Yes.
So, you know that why does this shape seem natural? Can you tell me, guys? Let's say if you want to press to preface this, I don't know how to drive a car, okay? So this is just me theorizing about it. So if you press, it's the first time you learn how to drive or something, and you press the gas pedal and you realize you've pressed it too hard, then you like put your foot more lightly on it, but you realize you pressed it too less, and then you find a middle way between that, and then you press it hard enough. Does it make sense what I said? That isn't it like this? Like you want to obtain this from the point on, you know, you want to obtain this, but you're never that accurate because you go below this line at first, then you try to compensate and you go above this line, and then you figure it out, right? Do you agree with this? Alexandra?
Yes.
Yeah, so it's kind of in the natural progression of things to overcompensate, undercompensate, and then boom, find the middle ground. And that is why for a long period of time in machine learning, we use this function to model the activation of neurons. because it seems natural, okay? But somehow we will see later on that this was a drawback due to some mathematical factors, okay? But for now on, to me, it seems only natural for me to use this activation function, right? So it starts, it is 0 up until 1 point, and it starts like this seamlessly to progress to 1, and from some point on it is clearly 1. Okay, what is the name of this function? Who can tell me? Do you know? Do you know the function that has this graph? How do you call it? Guys? Somebody, can anybody tell me?
Thing graph,
Yeah, I guess, yeah.
which is like half of a scene.
Yeah, but it's not like that. It's called sigmoid. Right? Do you agree with this?
Yeah, it looks like.
Also, I have another one that looks kind of like this. You were right to consider trigonometry for this, right? So, hyperbolic tangent. Guys? This one. What's the difference between the two? So the shape is the same, right? But what's the difference? What is the maximum value on the y and the minimum value?
Our starts from 0 and the
so sigmoid is between 0 and 1, right? You can see it here.
Okay, yeah.
And it's centered at 0 on the x-axis, right? It's also called the logistic function, okay? And the other one is located on the y-axis between -1 and 1, and also centered in the 0 on the x. Okay, do you guys follow? Do you know about this function? Did you use them before in your, I don't know, Mate Info adventure? So?
We didn't really remember the graphs.
Okay, okay. So, but now it makes sense, right?
Yeah.
Okay, good. So this is the one we're gonna use. Okay? Guys, do you agree? But now, the only thing we didn't discuss is how we are going to use this contraption, right? So, the idea is that we need to train it on the training data, right? So I'm starting with the first instance. I'm gonna put 0 and 0 here as the inputs from the first instance, I0. Then I'm gonna compute. I'm gonna assign random weights to this. So this is gonna be 0.2. This is gonna be 0.76. So, and let's put the free term as well, okay? I'm gonna put the free term to be, just tell me some value. 0.16. So, what happens next? Who can tell me?
Through the activation function.
So I need to compute the actual sum, ponderated sum. So it's gonna be 0 times, it doesn't matter, it's f of 0. So it's gonna be here, it's gonna be 0.5, right? Do you agree?
Why? So we do the computation x.
Well,
times...
x and y is 0, right? Oh, it's no,
yes.
it's for 0.16. Sorry, I forgot about the. So it's gonna be around here somewhere, right? It's gonna be 0.51 or something. Do you agree?
I don't understand. So we pass through that f, right? To the
Yeah, so what does it mean? It
function.
means that I need to compute this sum first, right? It's gonna be 0 times this, it doesn't matter, it gives 0. Plus,
Yes.
so put,
0.
and here we have the c, right?
So we have plus c.
Yeah, because it's the equation.
Oh, okay.
It's this equation we talked
Mhm.
about, right? Or gamma, if you will. Okay, so the sum is 0.16, okay? Do you agree?
Yes.
Okay, so now I go with this result and put it as an input here, like this is 0.16 in the sigmoid function, and I get a value close to 0.5, so let's put it 0.51, right? Do you agree? Hello?
I'm trying to think about it. I don't understand how we get from 0.16 to 0.51.
Well, look, this right here, all this inside the parentheses is 0.16. So if I have f of 0.16, where f is this.
Yes.
I go here on the x is on 0.16, and see which is the y value given by the function for 0.16, which is 0.51, which is in fact this one, right?
Okay, yeah, I got it.
And since this is greater than 0.5, I will assign it to 1, which is clearly wrong, right? Because it had to be 0. So my classifier is wrong. Why? Alexandra, why is it wrong?
I'm sorry, I have a question first.
Yeah.
Why did you say that 0.51 means that the result is 1?
Because it's above 0.5.
Shouldn't we have another step that formalizes this? Like, if the last input was greater than 0.5 or smaller, then the result is or 1.
Yeah, okay. So the idea is like I can just leave it like this if I want to use floats for z, okay? If not, I can like discreticize this with respect to 0.5, okay? But okay, let's say I don't do anything and I just get 0.51 here, okay? Do you agree with me?
Okay.
So what was the expected result that I wanted to get? 0, right? That's what I want, okay? So now let's see. Briggy, are you following?
Yes, I'm here.
Okay, so let's see what we did here. I'm gonna use a blue line. So I passed forward through my Perceptron. I fed data from this side, from the left side to the right side, and I got to this, right? But this is what I got, and this is what I expected, right? Oh, sorry. So it must not be working well, right? So this algorithm is a bit dumb. How do I make it wiser? Well, this is called feed forward. Let's use blue. Information, right? Because in a symmetric fashion with red, I'm saying that I need to go back, and based on how big the error is, I need to readjust what? Where is the error coming from, guys?
The weight.
Exactly. Okay, so it's from these guys right here. Okay, these are the ones that are wrong because the input data, it's constant, right? The output data, we know what it is, and we obtain something else in between. So the difference between what I obtained in module and what I wanted is called what?
Error.
An error. Okay, so if I'm going to call this, so plus c, so the result here is, this is gonna be the obtained value. This is gonna be the expected value. Okay, so O and E. Okay, so the error is in fact the module of O minus E or E minus O, whichever you want it. Okay, do you agree, guys?
Yes.
Okay, but E is in fact determined by what? By this and this and this, right? So these are actually parameters of a function. So you can say, because you can say E is a function based on W of X, W of Y, and C. Do you agree with this?
Yes.
And I said that this is equal to O minus E. And let's break it apart, okay? So this is equal to module of the f function over x times W of X plus Y times W of Y plus C. So this is in fact O. Do you agree with me? Minus
Yes.
E, which is a constant. Okay, so this one and this one and this one are in fact my instance. They're constants from my perspective, right? What is variable and what I need to modify are exactly these weights here. Do you agree? Because that they are the source of the error. That's why they are here as parameters, right? Guys?
That makes sense.
Okay, so I reduced my problem now to what? To reducing this error. Do you agree? So I started, you have to agree that this choice of weights here was arbitrary and not a very wise thing to do. Okay, so it's not intelligent. The intelligent part comes now, because I need to figure out a way to alter these weights such that what happens to this. So you can see, if I alter the parameters here, the function E alters as well, right? So I need to do what with this? With the error? It should go down to what? If I don't want errors.
No?
It should drop to 0, right? Do you agree? So that is my problem now. So I was in the other problem, the problem of making the computer learn how to do the AND operation. But now somehow, using this perceptron, I reached another problem. And my problem now is, after I put the input data here and here, I passed it, I multiplied it with randomly assigned weights, Wx, Wy, and C, applied an activation function that keeps it in 0 and 1, and obtained something that I didn't want to do, and I get an error based on this. I need to find an intelligent mechanism to not make the same mistake again for this particular set of input data, okay? This is exactly what I did as a kid, right? I had the input variables, I had to do some computation in mathematics, I obtained the result, I looked at the back of the book, and boom, my result doesn't add up to what's at the end of the book. So this is what I did. I just, like, I don't know, off the top of my head, without any knowledge, I just tried to work it using random weights. So the weights are wrong. I know the equation, but I'm using it wrong. So the idea is, what weights should I use so I can get 0, because I know it has to be 0 now, instead of 0.51, okay? This is the algorithm called what? If this is a feed forward of information, this is what? Who is the object here? What do I try to decrease? The
error.
Okay, so this is a back. Man, I'm gonna use red. A back propagation of error, right? So it goes back from the output back to the weights, right? And ultimately for this input, okay? Do you understand this? Questions so far? Alex, are you with us? Okay, so apparently not. Okay. Alexandra?
All clear for now.
Good. Andrada?
No, it's okay for now.
Andrea? Andrei?
She wrote that it's okay.
Yeah, cool. Andrei? I'm just taking attendance a little bit because we are way into the... But we need to cover this backpropagation part, okay? Because don't you worry, there'll be math involved, okay? Mathematics. Brigi? Monica?
Understood.
Monica?
It's okay.
Good. Okay, so let's see. How do we model this, okay? Clearly, I'm gonna need another blackboard. But I'm gonna put it to the left side of this. Okay. And we're gonna shift the space we are in again, okay? So somehow I kind of complicated things with this C here, okay? So let's just focus on... are you okay with the fact that we're only gonna focus on W X and WY? And we're gonna leave the C for... Because you will see why, okay? But do you understand? Does it make it more confusing to you if I lose the C now?
Oh, it's fine.
Okay, so actually I have the function of error that depends on Wx and Wy, okay? Yeah. And Wx and Wy, let's say that there are two real numbers. So I have this plane again, but now the coordinates of the plane are Wx and Wy, okay? So let's call these particular values, the initial values of Wx and Wy, let's call them Wx prime, and these are actual numbers from R, right? Wy prime. So they give me a point on this plane situated right here, which is the point Wx prime, Wy prime, okay? So on the z-axis, what do I have? Who can tell me? Alexandra?
Values from 0 to
Yeah, but what is that? It's this E, right? It's the graph of E. Do you agree? Okay, so again, let's see what E really is, right? So it's the modulus of f over x times wx plus y times wy, and I'm gonna lose the c, okay? Minus the expected value, right? All in modulus, correct?
Yes.
Okay, so we need to figure out how this function looks like, right? So how will it look like? Can you tell me? So in my case, for 0.2 here, and let's put concrete values, right? And 0.76, I will get 0.16, which gives me 0.51. So here, the point I'm trying to locate, like E of x, w, E of w x prime and wy prime.
Sorry, but didn't we lose the c?
Yeah. Let's say it is there, but I'm not plotting it on this surface, okay? C is like a constant here or something, okay? Because I don't want to put... So let's say that here on this, I have 0.51, right? Right? Do you agree? So this is the point I'm at. Guys, do you follow? Alexandra? So on the z-axis, I have 0.51, okay? Good. How does this error function look like as a graph? So this is a constant. Okay. Again, this is another constant. This is another constant. These are the exact values from here, the parameters of the function, so the parameters. So what do you think? This is a modulus. How does it look like, guys?
Plane.
I'm sorry?
Plane.
Plane? No, it's not a plane. Nope.
Okay. I was confused by the fact that there were only two variables. It's not a plane.
Yeah, so it's like what? It looks like... So E, you have to respond to this question in the form, how does E look like? And you're supposed to say, E looks like, and fill a name there.
Surface.
Yeah, but like the surface of what other element we didn't discuss? What's the only element that wasn't discussed so far? In the mathematical expression on the top. Well, you have E, you have these parameters, you have these constants. What's left? Come on, it's easy. What's there to... Guys, the only thing that we didn't discuss. So you have E, W's, X, Y, E. What about this guy, man? Come on, right? What about F? You cannot tell me that the shape of E has to do something with the shape of F. It's just the modulus applied on F. So instead, can you see that this is F of Wx, Wy? Do you agree? Those are the parameters. Alexandra.
Yeah.
So if you have a modulus on top of a function, which is then after that which you subtract a constant of, it had the shape of this has something to do with the shape of f, right, guys?
It should.
Right. Only let's see. So let's see how our sigmoid. Let's gonna check out 2D sigmoid plot online. Okay, let's see where I can. Okay, so this is what is. Okay, who can tell me the what should I put there for the sigmoid? It's a 3D, not 2D, right? So let's see if I have a function of more than one variable. Can I plot this better? Let's see. Let me. Man, I need a plotter for 3D. Do you guys know such a
GeoGebra.
Let me see if this works. What is this? Okay, this is not the. What is this, man? Okay, so which one do you suggest?
GeoGebra.
Can you write it down?
GeoGebra.
I don't hear the first part of the word. GeoGebra, sau cum ai zis?
GeoGebra.
Geo.
Geo.
Okay, thanks. So how do I use this, man? Come on, help me out. Let me GeoGebra 3D plot. Okay, this is it. Right, now we're cooking. Okay. So let's check a simple one. Okay, this is a plane, right? Guys, okay, let's start it like this. So this is a function, a linear function in 2 dimensions, right? So if I have, this is what this plane is, in fact. Okay, let me plus 5. Right? This is it, the plane. Do you agree? Guys?
Yes.
Okay, so now if I need to create the sigmoid into, let's see, sigmoid in 3D function. Sure, but so it looks like something like this, right? But we need to, let me just find the, so it's 1 over 1 plus e to the power minus x, okay? Can you tell me how I can write that? It's 1 over 1 plus e to the power minus 1. Okay. So, how? So, what? To the power minus x, okay, got it. It's 1 over 1 plus e to the power minus x. Okay, what if I have a y? What is the sigmoid in 2 dimensions? Where do I have it? Guys, help me out. How do I put it in the 2 dimensions?
I'm also looking.
So it's sigmoid of x and y. Okay. So also the y should be what if I put x plus y here? I don't think it's that one, but okay, if I have it like this, do you guys see it?
Yes.
Okay. So does it look like the side of a hill? Okay. Right? If it's like that, but let me check. So sigmoid function multiple dimensions. Okay. Ah, look. So it's plus, it's cool, right? So if you look at this, can you see what I'm seeing?
Yes.
So actually this is the summation of that, so I think it's that one. Okay, do you agree? So actually if I need some based on what I have, right, this would be, so the weights, and this is like this, because these 3 and these 2 right here is in fact given is given by the actual values of my input, right? So that's the x and the y basically. Do you guys get it? So actually the shape of, okay, if I put a modulus on this, so let's create the exact shape of the arrow, right? So I'm gonna have to put a modulus on this. Why did it? Okay, so I need to have put a modulus on the whole thing. Oh, oops. man. Ah, okay, I need to put it inside the modules. Okay. How do I do this? Come on.
Try, see, like in the lower part of your screen, there's like
Oh, yeah.
digits
Yeah, okay.
and operators.
Never mind the boomer, okay? Thank you.
I don't know if
Boom.
it will work.
Yeah, it works. Thank you. You're awesome. So, what's my error? It should be 0, right? It doesn't matter, but let's put it like this, right? Do you agree? So, I need to get rid of this. Do you agree with this?
Yeah.
So this is the shape of the environment in which I'm looking. What's on the blue axis? Can you tell me, guys?
It's E, isn't it?
Yeah, it's E, right? So if I'm looking here, like let me flip it so we can see. So if I'm going, where is my point located at? So on the red axis, on this axis right here, it should be X. So my X is 0, right? No. Ah, no, because my X is not, it's the weights. Okay. So here. So this is WX, it's 0.2, right? Right? So what I need is the point B for 0.2, 0.2. And what was the other one? 0. Point what?
0.7.
7.6 or something. That was like. Okay.
No, C was 0.16.
No, I meant WY. WY 0.76.
Like, aren't the weights the ones that you put in the formula? Like, if you go back, it's
No, but
3y plus 2x.
Okay, look here. Where was this? Oh man, it's the other plot. Okay, here. Look. So I'm trying to locate this point right here, in this space, right? So the one of the axes means WX, the other axis on the horizontal means WY, and the perpendicular axis Z is the error there, okay?
Yeah.
So this is 0.94, right? You know, if I was to think about this, it's close to 1 based on this, right?
Yes.
On this formula, okay? So it's around here somewhere, like on the hill, okay? But this is a cool environment, right? What do we need to do now? Do you like the shape of this environment? It brings me back to the great Snowdens of yesteryear, you know? Like when we were going like all the city of Alba Iulia was going out with the sledges, you know? Did you go? Kusania? Let's say, so we had one hill like this. It's a hill called Mamut, close to Alba Iulia, and you had one of these slopes like this exactly, and all the city was there, and we were all going down the slope. Okay. Do we need to go down this slope? Guys?
Yes.
Because we need it to be 0.
Exactly. So it doesn't matter where I am right now. If I have an error, I need to move from this point downwards, right? Up until I find a 0. In that point, it means I have different weights, right? Because the x and y axes are the weights of my algorithm, right? So if I'm located here, can you guys see my cursor?
Yes.
So if I'm here, does it make a difference that I go like this and reach here, the first 0, or like this and I reach here, the first 0, or like this and reach here, the first 0, and so on and so forth?
Your voice is ahead of the cursor, so it's kind of hard to
Okay,
figure
so
out what you
I'm
want
sorry.
to say.
So
I don't know
yeah,
if it's only for me.
okay, but how can I do this? Okay. I'm gonna create a snapshot of this. Where is this print screen? Cool. And then I'm gonna open the print. And then I'm gonna open it in Paint, I guess. Do I have... Man, okay, I'm gonna upload it in Paint somewhere. Okay. So guys, now let's say I'm here. Let's put some yellowy. Okay. So this is the point I am in, right? So does it make a difference that I slide like this and reach this point? Or I slide like this and reach this point? Or I slide like this and reach this point here? Or I slide like this and reach this point? You know, because I reach 0 on a multitude of points from where I am, where I'm at, right? Which is the best? And why?
The one that's shorter, that's because it's the fastest.
Okay, a good argument is that it's the fastest. I can agree with that. But there is another aspect here, okay? So let's say I go back to the scenario in which I'm a little kid who knows the answer at the end of the book, right? Where is that scenario? Here, right? So let me drag this to the right. Okay. So the idea is that I go and I watch that it's 0, I got 0.51, and then what I do is I adjust my weights here so that I get 0 somehow, okay? But the weights are not correct, but for this particular case it works, okay? Do you understand? So I think based on my experience, which is only one exercise solved, I think that the weights are good because if I give this and this, I'm very happy that I obtained the result. But it's just a coincidence that for this particular type of scenario, it works, right? However, when I go with the newly found weights for the next item, the next training instance, I will get 0.98, okay? Because this one is overwhelming. I was like, what? I thought I knew it, right? How can I be so off? Do you understand what I'm saying? Guys? Okay. So what I do now is I modify the weights again so I can fit this one. But what can happen is that I can mess up all the things I did beforehand for all these items here. So let's say I train myself for all these items, and here comes another example which throws me off balance, right? It's something I've never done before, and then it shatters my convictions of life because now I adjust the this weights very drastically to fit this one, but maybe I lose everything on like 3 of these ones. Do you think I have a danger of doing that?
Yes.
Right? So now if we go back to our scenario, right, here, Here we are. It makes sense to try to not only modify the weights in order to get a 0 value, but to modify the least amount of the weights to get that 0. So you need to find out the quickest way to get from where you are in the error landscape to a point with 0 error. Because that means that the perturbation you make for the weights is the least you can do with the greatest amount of error reduction. Do you agree? That means you risk to mess up the least amount of prior examples you already trained yourself for. Does it make sense? Guys?
Yes, it does.
Alexandra?
I was a bit confused because at the beginning it sounded like going from like setting a goal to minimize the error to 0 wasn't the optimal solution.
Well, I can minimize the goal to 0 on all the points here. The idea is that you have one point here which is the best out of all these points, right? And you need to find that one so that if you look on how much you move on the x and y axis, you need to move the least amount of distance possible with the same result of reducing the error. Do you understand? Do you agree to this?
Yeah.
So, Andrada?
I wasn't here for the whole explanation, so I need to rewatch the part.
Okay, we will recapitulate this whole principle, right? Because I think it's necessary. I find this fascinating, don't you guys? The way we use mathematics and computer science to try to mimic what nature already does so well. Briggy, what do you say?
I think we still don't appreciate it because we didn't see it we don't see it in action yet, kind of thing.
Okay, but did you get what I was saying here?
Yes.
Well,
yeah.
We will see it in action in the lab, okay? That's the idea of today. Okay, guys? Okay.
Will there still be a lab today?
Well, we'll see. Yeah, I mean, we'll get to that, but we need to finalize these theoretical aspects as well, okay? So the lab will go as follow. After I finish this, the whole discussion about backpropagation of errors, we will implement the perceptron, okay? So you will I mean, I can continue the lab as we finish the theoretical part, okay? But I need to understand that you get this principle, guys, okay? First, okay? So once we figure out everything that happens, we program. It's like I said from the beginning, right? We need to understand everything that happens in order to program what we want, right? Do you agree, Briggy? Monica? Bogdan, ești cu noi?
It's okay.
Da, să aici.
Alexandra, deci zi, te-am convins cu chestia asta? Have I convinced you?
Okay.
Does it make sense? Because to me, it kind of makes sense that I not only reach a point in this space that has error 0, but I reach the closest one with respect to the weights from my initial point, right? So how am I gonna achieve that one? Who can tell me? How can I slide down a slope, guys, mathematically speaking?
Carefully designing a function with the current error and the weights.
Okay, so yeah. Okay, so this point right here, right? Let me change the color to, I don't know, maybe this. Okay, so I'm here. I'm on position wx prime, wy prime. And I have an energy of E of this, right? How do I know where to go and with how much? I need to move to another point called wx second, wy second, okay? So guys, you did mathematics, right? You can help me with this. I need to go as deep as I can into the slope. The slope. I'm not hinting anything right here, but the slope. What's a slope in mathematics? Give me a synonym to a slope.
The tangent?
Another synonym to a tangent. It's good, it's not wrong, it's perfect, but I need another one. So, slope equals tangent equals what?
Sine over cosine.
Hai bă, serios acum, guys! Your mathematics and computer science, come on! What's a tangent?
Yeah, but we suck.
Huh?
Yeah, but we are really bad.
Nu,
at
nu, am
math.
auzit ce nu aia mă referam, zi răspunsul. Și vorbește română să nu mă baneze ăștia pe Twitch, man. Dacă zici.
Scuze.
So, Briggy, come on.
Direction.
What?
Direction.
No, man, it's the oh my god, guys, it's like the concept in mathematics that you used so often during these past 3 years, man.
The derivative.
The derivative, thank you. Come on, come on. It's the derivative. Slope equals tangent equals derivative, right? Do you agree? Let's explain what a derivative is, right? Can somebody tell me what a derivative is? Or a differential, for that matter. Guys? So, let's simplify the context, okay? Pum, I have a continuous function, blah, blah, blah. I have a dot x. Here, this is f of x. How do I define the derivative of a function in a point? Who can help me? Alexandra.
F of x minus f of x0.
Okay, so I need a conceptual point called x. Let's call it x plus delta x, right? So, let's see. We need to look at this from a philosophical perspective, guys, okay? So I'm gonna say, please tell me. So, you said it was a tangent, okay? So, let's see how the concept of a derivative fits into the concept of a tangent. So, the tangent in this point made between this line and this line is in fact it's the ratio between this line right here. I'm gonna color it with this. I'm sorry, it's the ratio between the red line, this one, and the horizontal yellow line, correct? So that's a tangent. So the tangent of if I have here I have an angle of alpha, the tangent of alpha is in fact this I don't know, how do I call it? Delta x, and this is delta y, right? So the tangent is delta y over delta x. But in order to depict delta y over delta x, I can do some more mathematical digging. So so the point here on the y-axis, right? So delta y is from here to here. This is delta y, and delta x is from here to here. This is delta x, right? So delta y, in fact, can be described as what I have here minus what I have here. In fact, this is f of x plus delta x, and this is f of x, right? And here it's clear, it's x and x plus delta x. So what this means is that the tangent of alpha is in fact delta y over delta x, which is f of x plus delta x minus f of x over x plus delta x minus x. Alexandra, do you agree? Hey, I can't hear you.
I said yes.
Okay, so who says how much this delta x means? Like if I put it twice as large, it will give me another tangent, right? So if I were to define the tangent in exactly the point x on the graph of f of x, I have to assume that the other conceptual point x plus delta x is very, 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 very close to x. Correct? Asymptotically close, right? Which means that this delta x should tend to 0, okay? So if instead of this delta x, I put a k, instead of it, I just use another denomination for this. So I'm gonna put a parameter k, and I go with this k to the limit. I'm saying limit of k going to 0, like I said, for this, then only then I get the tangent in the exact same point. Do you agree with this? Andrea? Bogdan?
Can you repeat again?
Okay. Weren't you paying attention? See, from where do you want me to repeat?
The last part with the equation you wrote.
So I said that a tangent to the alpha angle here is in fact this line here on the vertical axis, which is delta y, okay, over this line with yellow on the x-axis, which is delta x, okay. And actually, mathematically, if you look on the y-axis, we can see that we can write delta y as f of x plus delta x minus f of x. It means this segment minus this segment gives me this segment, right? So here on the x-axis, I have x plus delta x minus x, like mean this segment minus this segment gives me this segment, okay? And the ratio between them gives me the tangent of alpha. However, if I were to put a greater delta x, like more to the right, I would give another ratio which is clearly different because the function is convex, right? I guess. So it's continuous and it's not a line, so it must give me another tangent for another alpha, right? Which means if I need to find out what the tangent is in particularly the x point, I need to model a conceptual point that is very close to x, meaning that this delta x, the difference between this point and x, should tend to 0. So I redenominated delta x to k, and I said that if I was to take k to the limit to 0, I would get the exact value of the tangent in that point. Does it make sense now, Andrea?
Yes.
Okay, so this limit is my derivative of the function. It's like this. It's the derivative of function f, which is continuous and derivable, on the point with respect to point x in that particular point. Do you agree? Because do you agree, Andrea?
Yes.
So here I could have written delta of f of x if you want. And that is why if I go to the limit to a very small limit, this is capital delta and this is the small delta, and that is how we explain the notation as well, because it's actually the infinitesimal impact of a small perturbance in x over the function f. Okay, so if we were to think of the derivative from a philosophical perspective of its meaning, you know what I'm saying? You will find out that the derivative is in fact the impact that a small perturbation in the parameter of the function has on the value of the function. Do you agree?
Yes.
Alexandra? Okay, so with this in mind, can we use this derivative to move down the slope? So I'm on a point x now. I need to move to another point x prime, which is closer to this. What do I need to do? Hey, Alexandra.
Yes.
What do I need to do to move closer into this? I have two scenarios, right? I need to go to the left, like Beyonce, or if the slope is like this, I need to go to the right, right? How is the slope here? What is the value of the tangent on the or the derivative in this case, and how is it in this case? Like, yeah, I have to go like this or like this. So the slope is either like this or like this. What is the slope of a function that's like this?
Negative.
What?
It's 0.
It's 0, man. Come on. The slope,
But
the degree.
oh, that line. Okay.
Oh, I'm sorry. Okay, so what if it's like this? Or like this?
One.
So what if it's like this? If the angle is like this, and now the angle is like this. Guys, come on, tell me. Who can tell me? Briggy.
In the first case, it is greater than 0. In the other, it's smaller than 0.
Okay. Now here, it's the same three cases we talked about before, right? Greater, smaller. Do you agree? how can I tell? Well, man, let's think. If you go increasing in this direction, then f of x plus whatever is gonna be greater than this. So this it will be greater than 0, right? And the other stuff here, this is always, if I go up, this is always gonna go greater than 0. So the result will be greater than 0. If instead it's the other way around, this will be smaller than you already have, and you have some negative onto something positive. That means you're gonna have the ratio will be negative, right? Does it make sense, Alexandra?
Yes.
Good. So now, if I need to go down, right? So my f value needs to decrease. What do I need to do? Do I need to add or remove, add or subtract this from x? Think of the two cases, right? Because now, in this case, I need to go, x needs to get smaller, and in this case, x needs to get greater. So that means if the derivative is positive, I need to deduct it, right? So it's gonna be something like this. Guys? Does it make sense? Andrada? Bogdan? Guys, can you hear me? Brigi? Can you hear me? I don't even know if you guys can hear me. Brigi? Okay. So, Alexandra, does it make sense? It stands, right? From a mathematical perspective to deduct it.
So you deduct the derivative
times the value.
Of okay, y times the value.
Well, I have to multiply it with something, right? Right? Because this is just a factor, right? So I'm moving in this with some...
Okay, okay.
Okay? So
okay,
this is
fine.
just the factor to which I'm moving, right?
Okay.
Okay. So, but I was just trying to check if I thought correctly. So if it's a slope, the slope is positive, I need to subtract, and if it's negative, I need to subtract as well. So it goes like this. Because in my book it's correct, but I want you to confirm that for me. Because if I have this and this is a positive value, right? It will move in the good direction, right?
It will.
And it's regardless of the sign of the tangent, right? Because it works. Okay. So that means with every step I take, I get one step closer to the 0 of the function. Do you agree?
Yes.
So now I know what I need to do to go down this slope as steepest as I can, right? So, agreed? It gets me here if I take the steepest approach. How do I do this? What do I need to compute in this respect? Because now I have two different dimensions, right? So I need to modify, I need two equations. I need W, oh man, let me change the color. So I need this one, right? So Wx second has to be Wx prime minus some derivative multiplied with him, right? Do you agree? Which would be this derivative?
Yes.
Which would be this derivative? Did you do partial derivatives?
Did.
Hmm?
Did.
So it's gonna be the derivative of E with respect to Wx prime. Wx. I'm sorry, not Wx prime, Wx, correct? So this is in fact a function that has two variables, which is, this is the complete notation, Wx, Wy, and you can compute the derivative with either with respect to Wx or with respect to Wy, right? So this is the complete notation of what I wrote there, right, guys? Andrea, are you following? Come on, guys. Bogdan, mai ești? Monica?
Sunt aici.
Is this boring? Because we're getting to the end of this.
No.
Okay. Alexandra?
Yeah, I'm a bit lost. Why do we use Wx simple, not prime?
Because it's
That
the
equation.
dimension, right? If I have a function f of x and y, and I do the derivative of this, it's gonna be with respect to x, not with x0 equal 3. Right? It's with the name of the variable, not the actual value on the variable.
Okay, sorry. Okay.
Right? So it's clear now, right? So this is for the Wx prime, and also I need to do Wy second equals Wy prime minus the derivative of E. Oh man. The derivative of E with respect to Wy times Wy prime. Is it okay? Alexandra?
Yep.
So what any motion in 2D, okay? It can be, if you look at vectors, you know, it can be split into the two versors, right? If I move, I can the vector of displacement is just the composition of a vector I times something plus a vector j times something. Do you agree? So if I were to move in this direction, that movement can be split on both the axes, which is I and j, x and y, right? So this is what we're doing here. I need to find out where should I move on the y and where should I move on the x axis, right? So if I know how to move to the left or to the right on up and down, the composition of the two gives me the location on this Cartesian plane, right? Alexandra? Does it make sense?
It does.
So what I need to do is to find out what this steepest descent means. Did we talk about this before? Does this seem familiar to you guys? Did we talk about gradient descent? So okay, we have another synonym there. Let's put it on the blackboard, right? Do we have some sort of a synonym in the sense of gradient? What's a gradient? How would you describe it in Romanian, the term of gradient? Alexandra.
Depinde, ca concept matematic sau ca idee?
Nu, gen în Photoshop.
O tranziție.
Păi și în română cum zice? Într-un cuvânt. Degradeu, nu? Nu? Deci o tranziție smooth. Exact ce avem noi aici. Asta e, nu? Când făceai chestia aia de... Când făceai un degradé în Photoshop, îi dădeai punctul... că tot vorbeam... Let's go back to... Which one was it? I think here. No, the sigmoid graph. Is it here? So how did we come up with the sigmoid graph? We established the median, and then we established how far does the gradient go. If I... No? You remember the gradient tool in Photoshop? Monica?
I didn't really work with Photoshop.
But the idea is you set a point, and then you set how much do you want how slow do you want it to degrade to the sides, right? And this is exactly what I control here. I control the mean of the slope, the middle point, and then how steep is the slope with respect to that. Alexandra. And that's the gradient. Why is this blocked? Okay, I need to close some of these. Holy guacamole. Do you guys hear me now? Yeah, I just need... My computer is over flooded with information right now. I need to close some of this. Oh man. Let me just see what I can do. I didn't realize I was opening so many tabs. So I'm gonna close a lot. Oh, smokes. Maybe I can close Skype. Guys.